All right, so welcome everybody. Today we're going to be talking about PowerMill Ultimate 2021. However, a lot of the features that I'll be showing are also available in prior releases as well if you are working with a prior release or you're interested in purchasing something prior to 2021. So recently IMAGINiT has started to provide a couple of more advanced CNC programming softwares. In that group is PowerMill, as well as FeatureCam and PartMaker. We'll be doing another webinar on FeatureCam in a couple of weeks, so put that on the calendar if you haven't already. I have my email listed on here, so if you have any questions, follow-up questions after the webinar, or you need to reach out to me directly with something, feel free to. I can either help you out or I can get you connected with someone that can. So my email is listed right here on this opening screen. So let's talk a little bit about PowerMill 2021. So the focus of today's webcast is going to be on automation. So some of the things we can do to streamline our programming efforts so that we're not spending as much time programming, but also so that we can improve the quality and the consistency of our parts that we are programming with our machine. So PowerMill is intended for really complex components. So it actually was born from the mold and die industry, where high surface finish tolerances as well as complex machining strategies are required. So it works great for 2- and 3-axis milling, surface finishing, but you also have the flexibility to control your 5-axis machine and get the most out of your 5-axis machine. So if you're investing in these more complex CNC machines, it's important to have a software that allows you to utilize them at full capacity, and PowerMill is one of those softwares that's going to do that for you. So sort of some key messages with PowerMill, some things to keep in mind if you are considering upgrading to PowerMill moving forward. Just keep in mind that you get a lot of the really high speed strategies that are included with something like an inventor cam. So you're going to be getting that vortex, that adaptive clearing strategies. You're going to be able to create toolpaths really quickly. So the actual generation of the toolpath is extremely fast, but also the toolpath is going to be more efficient at removing material when you're roughing and when you're finishing. So you're going to be reducing your programming times, but also the run time on the machine. So time is money. It's important to save not only on the front end when programming, but also when you're running the toolpath, making sure that you're being as efficient as possible. We also get full programming capability of your 5-axis. So not only can you just do simple 5-axis surfacing, you can completely control the indexing of that CNC head or of the table. So if you have a 5-axis CNC, you can completely control the position of the tool axis at any point in the toolpath. So once you've created your toolpath, you can go in and modify the tool axis to manually position it exactly where you want it at any stage in the toolpath, which gives you full, complete control of that head, and you're not guessing at what position the B or the C axis is going to be in. So what this is going to do is it's going to improve your part quality, and you shouldn't need any manual polishing after it comes off the mill. It should be completely ready to go, finished, and hitting your tolerances. And then the last really important thing with PowerMill is it has some of the best collision avoidance capability in the suite. So what the PowerMill collision avoidance technology is going to do is it's going to check for collisions when you calculate the toolpath. So when you first generate your toolpath, it'll look for collisions between the tool and the holder with your workpiece or with your fixture. It's also going to check a second time when you simulate. So when you go to simulate, you can do a full machine simulation, which includes the stock, the fixturing, but also the table, the head, the walls, everything in that machine you can simulate together really smoothly. And what this allows you to do is confirm that not only are there not collisions between the shaft and the holder, but also you can make sure there aren't collisions between the head of the machine and your workpiece or your fixturing, especially in a 5-axis operation. That's extremely important to make sure you understand exactly where your holder and the head of the machine are at all times. So you're going to be protecting your equipment, but also gaining confidence in programming that 5-axis because you're going to be certain that it can run unattended. So looking at where PowerMill falls in, if you're not familiar with it already, basically if you are coming over from Inventor HSM or something similar like Fusion Cam, that's where you get the integrated CAD, which means if you make an update to the model, it automatically can update the toolpath really quickly. Everything is saved within one file type. FeatureCam and PowerMill right now are standalone softwares, which means if you're not using Inventor, maybe you're using SolidWorks or Creo or CATIA, whatever platform you're coming from, these are standalone softwares, which means you can just import your model in as a solid body. So a step file, an IGES file. Once it's in FeatureCam or PowerMill, then you can add in these toolpaths. And there's quite a bit of flexibility with FeatureCam. FeatureCam is a little bit more automated. And again, we're going to be doing a webinar in a couple weeks on it. PowerMill is sort of it can do a little bit of everything. It's really good at doing your surface finishing. So when you get into the multi-axis machining, that's where you're going to really be able to take advantage of PowerMill. When you get into complex multi-axis, tool axis editing, quick toolpath editing. So if you need to just remove a segment of your toolpath, you can do that without having to regenerate. And then if you are considering upgrading to some robotics, you can do robot programming as well. So if you are still just doing 3-axis and simple 5-axis, just keep in mind with PowerMill, it gives you that ability to scale. So if you are looking at investing in a higher end 5-axis machine or a robot, PowerMill is going to help you program that as well. So you have that flexibility moving forward. So just some examples, mold and die, that industry has been using PowerMill for a while, and that's really where it's going to excel when you have a lot of complex surfaces with different slopes and grades, tight corners, undercuts, all of those things can be done easily with PowerMill. A lot of that stuff will come in and play well in the aerospace and automotive industry as well, where you have high volumes, but also complex components that you need to program efficiently, and you are most likely going to use a 5-axis machine to avoid additional setup time. And then in general, complex components where you have complex surfaces like blades and blisks. Maybe you're doing some port machining. Maybe you're doing some really complex undercut features. Again, PowerMill is going to really excel in those areas. So if you don't do any of these types of parts, don't leave the webinar yet. It can also help you program simple parts, which I'll show you with some feature recognition. Just keep in mind that this is where you're going to gain the most from it, is when you're getting into complex components. So there's some picture components where you've got a lot of different surfaces. You have some flat areas, you have some holes, but then you also have a lot of different angles and tight corners that require some 5-axis finishing. So with these types of parts, could you get there with something like Inventor Cam? Potentially, but you're going to have a hard time. It's going to take a long time to program. And also, you're not going to have that confidence. You may not be getting the surface finish you need, and it may not be safe to run because you can't do that full machine simulation. So these types of parts are going to run well with PowerMill. All right, so let's talk a little bit about what I'm going to focus on today. I'm going to be diving into some automation features in PowerMill. I'm just going to kind of step through each of these and show you a couple of examples. I'm not going to go through programming an entire part start to finish or anything like that. I just want to make sure you guys can see some of the advantages you get with PowerMill when it comes to automation. So one of those things is intelligent strategies. What that means is toolpath strategies that do some of the hard work for you. One really good example of that is a steep and shallow finishing toolpath. It automatically identifies where you have different angles of surfaces in your model. So let's say you have a flat surface. On those areas, it's going to use what's called a spiral scalloped finish toolpath. Anywhere you have a really steep wall, so like almost a vertical wall, maybe it's at like 60 degrees, it's going to switch to using a contour or a constant Z finishing strategy. So steep and shallow will automatically determine what toolpath to apply in those areas for you. So it's automated. You don't have to go and take measurements yourself. You don't have to try different toolpaths until you find one that works. It automatically determines that for you, and it creates a nice, smooth transition from one area to the next. So it's going to save you a ton of time on the front end. Another thing is automatic collision avoidance. So Again, we can detect collisions on the front end when we create the toolpath, but then again, we can also have the ability to simulate the full machine and use 5-axis collision avoidance to prevent gouges or any sort of damage to the holder or to the machine. Programming automation, so I'm going to show you guys how to create a macro. Macros are one of the best ways to program with PowerMill. Macros allow you to actually record your every single button click. So if you want, you can actually record yourself programming a part start to finish and save that recording. And what it does is it actually creates a script that you can run. And that macro will then use the same steps and the same approach that you used when you programmed one part on any additional parts you'd like to use. So you can create these macros so that you can not only improve the speed that you're programming, but you can also improve consistency across the board. So if you have a team of 10 different programmers, if you're all using the same macros, things will be consistent and you'll be able to program more parts. And then lastly, feature recognition. So I'm going to show you a little bit of the feature recognition that PowerMill has built in. When you're doing a more prismatic part with some pockets and holes and things like that, feature recognition will help save you time creating boundaries and trying to select surfaces. It automatically creates those features so that you can do more of a feature-based machining strategy instead of a global surface recognition strategy. So we'll talk a little bit about that as we go through. All right, before I jump into the demo, just some things to think about. Some of the benefits here with our automation. Number one, increased confidence. So we're going to be able to improve the confidence that the toolpath is going to run smoothly without any issues. We're not going to be scared of any collisions because we can confirm that all on the front end. Also, we're going to be confident that the actual resulting part is going to meet tolerances. It's also going to not require any sort of manual polishing or touch-ups after the fact. We're going to protect our hardware investment. So you're buying these expensive CNC machines. You want them to run a long time. It's important to protect it by purchasing a software that's going to be efficient but also safe. Repeatability and standardization. So that's where those macros come into play. We can repeat the same type of programming over and over again without missing a step or missing a key setting. That's going to make sure that we can continue to produce the same quality of part over and over again and not have any rework. And then lastly, reduced machine downtime. You'll be able to run the machine unattended, but also you're going to avoid damaging the machine. If you were to damage a tool or damage a holder, your machine can be down a week, or you're waiting for that replacement part, or you're waiting for a tech to come out and look at it. So to avoid those week or 2 week delays, just make sure that your machine's going to run efficiently and you're not going to have those damaging toolpaths. All right, so let's jump into PowerMill a little bit. I'm going to give you a little tour of these features so that you can get familiar with what you're getting with PowerMill 2021. First thing I'm going to talk about is the ability to check for collisions while you're running and generating your toolpath. So when you go to create a toolpath, let's say I'm creating a new toolpath here. We'll do let's say we're going to do a steep and shallow. I'm going to go ahead and look at finishing the surfaces on this part. When you're generating a toolpath, you'll notice there's this automatic verification setting. What this does is it's going to check for collisions with the model for the holder and the shank. So it's going to make sure that there aren't any collisions in those areas. So you can automatically confirm on the front end. So when it generates the toolpath, it's going to go through a process of checking. And then you'll see when the toolpath is generated on the left-hand side here, you'll see next to the toolpath, there's these blue check marks. That means that it's verified that there aren't any collisions between the holder or the shank and the model. So those toolpaths are safe to run. Again, you can then check for secondary collisions when you simulate, but this makes sure that on the front end, when you first generate this toolpath, it does the checking automatically for you. So you don't have to go through and simulate to verify. It checks it for you and assures that your toolpath is safe. Now, what you can also do is you can actually change the tool axis to use 5-axis collision avoidance. So the tool axis, I can also turn on automatic collision avoidance. And what that will do, if I apply that, is it will determine areas where maybe the tool can't quite reach at a vertical orientation, and it uses those additional 4th and 5th axis controls to move the tool so that it no longer collides. So what that does is not only does it check for collisions, it also will manipulate your toolpath to avoid potential collisions. Let me show you guys what that looks like. So I'll go ahead and activate this finishing toolpath here. So this toolpath, all I'm doing is I'm coming in and I'm finishing these fillets in these tight corners. So in this toolpath, there are going to be a couple areas where looking at this tool, it might not be able to reach down into this deep pocket to finish those fillets. So this might require an additional 4th or 5th axis orientation. So if I jump over to simulation, and let's just go ahead and simulate this guy. You'll notice as I start to simulate this, if I look at it from the side here, you can see that it initially right here adjusted that 4th and 5th axis to tilt the tool so that it can reach that tight corner at the bottom there. So I didn't have to go and tell it exactly what orientation to put the tool in to avoid it. It determined that there was a collision there, and it used the automatic collision avoidance to tilt the tool an appropriate amount, not more than necessary, just enough to avoid that collision and make sure that it can go ahead and reach that fillet at the bottom there. So as it's simulating here, you can see that it tilts the tool in all those areas that it was going to collide with the holder, that red section there. So that's what's really neat about PowerMill, is that it's going to check for collisions, but also give you that flexibility if you have a 5-axis machine to regenerate a toolpath that uses those axes to avoid the collision. Now, another way that it automates on the front end is going to be your toolpath strategy. So looking at this steep and shallow toolpath. So this is the steep and shallow toolpath I generated for this part. Now, looking at the part, you have all sorts of different surfaces. Some of them are steep, some are shallow, some are flat. And so what this does is, if I zoom in here, real close, you can see that on the flat surface, it's using a spiral, a constant step over scallop operation. And then as soon as it gets to this vertical wall where it's steep, it switches to a constant Z step down strategy. So this will make sure that the surface finish on the shallow areas is extremely good. And then it smoothly transitions into the steep area, switching to a Z step over. So this is a way that PowerMill is going to automate the actual toolpath itself, so that you don't have to go through and look at this part and set boundaries and figure out, where should I be using the contour, where should I use the scallop. It automatically determines those for you and builds a very smooth transition. So the way this is controlled, just kind of a quick high-level overview, is what's called the threshold angle. So when you're setting your steep and shallow toolpath, this threshold angle of 30 degrees means that anything that is steeper than 30 degrees, so once you get to these vertical walls here that are steeper than 30 degrees, that's where it switches over to using a steep constant step down. And then anywhere that it's shallower than 30 degrees and close to flat, it switches to using a scallop step over spiral instead of that steep step down. So just some takeaways: PowerMill is going to automate the collision checking as well as the tool axis modification. It's also going to automate the actual calculation of your finishing toolpath. So it's going to determine where those transitions occur and how to build a finishing toolpath that is going to be really efficient and really give you a nice surface finish throughout the entire part, regardless of the complexity of the component. All right. So next automation feature is going to be our feature recognition. Let me open up a different part that has a couple of components in it that are a little bit more prismatic. So these are components that are You know, maybe you've got some pockets, some holes, something a little bit simpler than what I just showed. This is just a simple wheel hub here. And you can see that it's got a few pockets, it's got a couple fillets and counter bore holes, you know, fairly simple. And with a part like this, it might be easier and more efficient to program it using feature machining. So identifying the features up front and then choosing a toolpath specific for that feature, whether it's a hole, a pocket, or a side. So once you've built your setup, all you need to do is create your feature groups. So in order to do that, I'm going to go ahead and click on Automatic Feature Recognition. It asks me if I'd like to select features or just detect all. So I can select each one of these individually. But in this case, maybe I want to just go ahead and grab everything in here. So I'll click Detect All. It finds all of the pockets, all of the contours that need to be removed, and it generates them as individual features. So I'll just click Accept. And keep in mind, this works with any type of model you bring in. So if you're coming over from Inventor or SolidWorks, or you just have a step file, it will recognize these features. It doesn't have to be in a specific format. So everything in pink here are features that have been recognized. So now I can continue to program as I would normally, but when I go to create a toolpath, I can use these feature machining strategies without having to create a boundary. It's already created all of the boundaries, and you'll notice that it extends them to the top of the stock on those middle pockets. So I can assure that I'm going to be creating a toolpath without a whole lot of manual modifications. So let's just go ahead and just do a quick feature area clearance on this outside contour. So I'll go ahead and click OK. We're going to kind of clear the material outside of this part as kind of my first operation. So first I have to choose what features I'd like to use. So it automatically selects all of them, but I'm just going to go ahead and just select this outer boundary. That's what I want to start with. So I can group a couple of features together, or I can just kind of work through one by one. So we're going to select the outer feature here. And then I can just go ahead and make sure that the tool, I already selected the tool, so I don't need to work with that, but I'm going to use a high-speed vortex strategy. So it's going to be sort of like the adaptive clearing strategy in VentorCam. This is a high-speed strategy that maintains a constant chip load and will be efficient. For my step over, let's see, my tool is about ½ an inch. So let's just use like 40%. And then step down, let's use maybe an inch at the most. To make a couple manual changes, remove unsafe segments. I'm going to go ahead and do automatic collision checking. So again, it's going to check against the model in stock to make sure there aren't any collisions. And I can go ahead and just calculate. I'm going to rename this too. We'll call this outside rough operation. Calculate. And let me go switch the feature here. There we go. Let me reset this. Looks like I grabbed the wrong feature group here. There we go. So give me a second here. We'll reset the strategy, and then for my feature, we'll grab not sure what's going on here. Of course, as I do the demo, I'm getting some issues. Give me a second. Well, we'll come back to this. I don't know what's going on with this part, but I'll just go ahead and close it for now, and we'll jump over to another feature here. Not sure what happened. Sorry about that, guys. So let's go ahead and talk about macros, because that's kind of what I wanted to focus on here. And with the macros, what I can do is, let me go ahead and open this part back up here. So let's say I want to automate the full setup, programming, calculation, everything in my model. I can do that with a macro feature. So with a macro, what I can do is, it's really straightforward. You don't have to really have a lot of like background in coding or anything. All you need to do is go to this macro panel and basically select record. As soon as I select record, I can basically create a new recording of everything that I'm doing, and it's going to save that, and then you can rerun that on additional models. So basically I would select record, and we'll just go ahead and save this into the roughing folder I have here. Let's just call this setup rough macro. I'm going to do a quick setup and then add in a roughing operation. These are things that you're probably going to do very similar for a lot of parts, so it makes sense to kind of build macros for things that are going to be similar across the board. So record is on, so now everything that I do, it will record and then apply to the next component. So the first thing I'm going to do is create a setup. So it's going to actually automate everything, including the setup, the stock calculation, the tool creation. It's going to grab everything. We'll create a new stock setup. We're going to go ahead and generate a cylindrical stock, or calculate my stock. Work plane, I'm going to set my work coordinate system. We'll just go ahead and touch off on the top of our stock body, something like that. And then maybe I want to always create a couple of tools. I could go grab some tools from a database or just create a new tool. So let's say I just want to create a simple end mill. This is going to be, maybe 3 inches. Let's make it 2 inches, and let's make it a 3/4 inch flat end mill. We'll make it tool number 1. Close. So now, as I go through and I create, for instance, a toolpath, let's say I create just a simple model area clearance toolpath, it's going to save every button click. We're actually working from the top here. So let's say I just do a vortex. We're going to do a couple of different settings here. It's going to save all of these. So whatever settings I apply to my toolpath. So let's just go ahead and add in a couple of different things. Automatic collision checking. We'll rename this. It even saves the naming. And any boundary creation that you do, it's going to grab everything. So I just calculate a toolpath here for a roughing operation. It creates our roughing toolpath for us on this side of the part. And now if I were to go and end the recording, now if I were to open a new part and you go to run, I can run the setup rough macro. And what's in here, if I open it up with like a notepad, this macro basically has each line of code. So you'll see that it says accept setup, create end mill tool, length 2 inches, diameter 3/4 inches. Every single command that I created while programming this part is saved into this macro. So you can come in here and you can modify any of these values in the macro, and it'll update what is actually performed on the part that you're running this on. So it builds this form, it builds this text macro for you, and you can then apply it wherever you want. I'll show you an example of this on a different part. With this part, what we'll do is I created a macro that's going to do a number of things. It's going to generate my block setup. It's going to select my work coordinate system. It's going to rename my setup. It's going to rename my coordinate system. It's going to create 3 tools. I'm going to create a couple of end mills and a ball nose mill. It's going to create a roughing strategy. It's going to do a rest roughing strategy. So it's going to do a secondary roughing operation. Then it's going to apply a steep and shallow toolpath and go through generating from start to finish. So once I load the macro, it's going to step through each of those all the way start to finish without having to do anything. So all I have to do is open the part. I actually don't have to build a setup or anything like that or do any pre-processing. As soon as I import this into PowerMill, it's ready to run the macro because my macro is going to do all the setup parameters for me. So we'll go to run, and I'm going to go to my folder here I have for complete macros. This one is the setup rough finish macro, so it's going to set the part up, rough it, and finish it. We'll click open. So it generated a block box, and it automatically sized it to my stock. So it sized it to the right size. It generated a end mill and then a roughing operation, so my first roughing operation. Then it's going to create a smaller end mill. So it creates a smaller end mill. And now it's going to pull my initial roughing and create a rest roughing operation. So that's what it's doing right now. It's calculating our area and doing a little bit of rest roughing with the smaller tool. Just like that. So it's done with that. Now it's going to grab our ball nose mill. So I create a small ball nose mill, and it's going to go ahead and just apply a steep and shallow finishing operation to the entire part. So I can go back and I can trim away segments that I don't want, but it does it on the entire part automatically. So now I'm leveraging not only the macro, but also the steep and shallow toolpath, because it's going to again use a spiral step over on the flat surface, and then as it gets to this cavity right here, it switches to a constant Z step over. So it's going to automatically generate that, automatically pull in the correct tool that I require. And at this point, if you look at the setup, it renamed my setup op1, because that's typically how I name my first setup. It renamed my toolpaths rough, rest rough, and finish. And it generated them all the way start to finish. So you get maximum use of the software using these macros. So in this case, I programmed, obviously the setup and, multiple operations, but you can also use them to kind of program individual feature-based operations. So maybe you want to create a macro for setups. You want to create a macro for roughing pockets. You could create a macro for doing finishing surfaces like this. You can have several that you run on the same part file. You're not limited to running just one. So it's a really great technique. And this is going to help you improve, obviously, the quality of your parts and consistency. But also, if you have a new employee that maybe isn't super familiar with the software, you can set them up with some macros to help them program simple parts, but also learn, what strategies you prefer to use in your shop and what type of settings work best with your machines. You'll also notice with this, you get the ability to do that automatic verification. So it automatically generates these toolpaths, but it also verified that there aren't any collisions. So I get toolpaths that are ready to run without actually clicking any buttons, but also I know that they're going to be safe to run on my machine. So you kind of get the full range there, start to finish. It's going to be efficient, but also safe. So one thing I wanted to highlight here before I wrap up the demo is looking at that component we had up earlier. I mentioned that you can do full machine simulation. Now, all we've done so far is checked for collisions with the holder and the shank, which is great. But when you're running a 5-axis machine, so when we're running this finishing pass, we're diving into these deep corners, you also want to be able to check for collisions between the holder and the part and the fixturing. So to do that, I can load in and create a machine tool. So these machine tools, I'm going to turn it on, basically will show the full head of the machine, the table, the fixturing, anything you want in there. And it's going to show the actual motion of the head and the axes twisting and turning. So let's go ahead and simulate our corner finishing toolpath here. So we'll load this back in. We have our tool, our holder, the machine head, everything's going to be simulated together. So even though we've already verified collisions on the front end, when we run the full machine simulation, it checks for collisions again. So let's go ahead and play the simulation. It's going to move the machine around. You can see the head rotating around. And then it comes up with a warning. So it automatically looked in the background and found that there was a collision between the head and the model. So this is something that was not checked for ahead of time. So let's rotate this around. And you can see right up here, you can see the actual head of the machine just barely touch the stock, not the stock, the actual model there. And that's a little concerning. Obviously, we don't want to damage the head of the machine there. So at this point, you know, I could go back and I could try to tweak a couple of settings so that I don't go to the full depth, or maybe try to do a longer tool or a different position. But if I am sort of planning on using this tool in this machine, I don't want to have to try to reconfigure. I have a 5-axis machine, so this shouldn't be an issue. So what I can do is I can go to what's called our dynamic machine control, and I can really quickly move the machine and update the toolpath without having to start over. So I'll go ahead and click on the dynamic machine control. And I know that the segment kind of prior to and immediately after this collision are probably needing some modifications to make sure that it sweeps away from the workpiece at this point in time. So what I'll do is I'll go ahead and modify that segment. So we'll go ahead and just select, you know, maybe just this entire region of the toolpath where we saw the collision. So I'm going to select this section in white around the collision. And we're just going to go ahead and grab onto these tool axes and move the actual head. So I'm going to rotate the head maybe 35 degrees in one direction, then I'm going to come down away from the part, maybe 30 degrees. So now the head should be well clear of that collision and still engaging that fillet the way that I want it to. So that will help me avoid that issue. So I'll go ahead and just update that region. So it only updates the toolpath in that area. I don't have to start over. So we'll go ahead and accept the changes. I'm going to go back to our simulation. And let's go ahead and run it again. So again, I'm not regenerating anything. All I'm doing is restarting the simulation. And PowerMill is intelligent enough to update that segment and blend it into the remaining segments so that what happens is when I simulate this, it's going to go ahead and machine, and then right here, you'll notice it changed the position of the machine right where that collision was. So I'll play it from here. And then goes back to the rest of the operation. So as soon as it gets to that segment, it rotates the machine down 30 and 30 in each direction. And then I can continue to verify the rest of the toolpath, make sure there aren't any other collisions. And again, it's going to use 5-axis moves to avoid the collisions with the holder, but then you may need to add these additional axis modifications when you get into the full machine simulation, just to make sure that you have enough clearance to do those tight corners. So it's very intelligent, very easy to use. It does the checking for you, and then all you need to do is just sort of modify that axis sweep a little bit, check the simulation, and then this is ready to post out and run on the machine. I don't have to go recalculate anything. So just to summarize, you know, we've got those intelligent strategies, the steep and shallow, automatic calculation. We have automatic collision avoidance, so we're avoiding collisions with the shank and holder, but also doing full machine collision detection. We can automate the actual programming with our macros, so we can go step by step programming a part and then apply that to secondary part. And we also have some feature recognition tools, which I had a little bit of trouble with today for some reason on that part. But with that feature recognition, you can automatically grab onto holes and pockets and then throw in the program that you need without having to go through the process of making those face selections. It'll automatically recognize those for you. All right, that pretty much wraps things up for what I wanted to show with the demo. Again, just wanted to step through some of those features that you get with PowerMill 2021. At this point, Lori, we can go ahead and open this up to a little bit of Q&A. If there's anything that piqued your interest, or you wanted confirmation on something, feel free to submit some questions, and we'll go through a few of those here to wrap things up.